So when you're trying to figure out the density of a regularly shaped object, it's actually really easy. Okay, so all you have to do is just measure the sides of the object, and then you can use your volume formula. Let me get my pen back here real quick, because I keep forgetting that. Okay, volume equals length times width times height. Okay, and that will give you the volume of any regularly shaped object. So or that will give you the volume of like a cube or a rectangularly shaped object. Okay. Now, of course, you have your different volume formulas for like if it's a pyramid versus a sphere, yada, yada, yada. We won't get that complex. This is just volume equals length times width times height. Okay. So that's really great if you have a cube or a rectangle, but if you have kind of an odd-shaped object, so an irregularly shaped object, you need to actually have a different way for calculating the volume. Okay, so it was actually Archimedes who discovered this, and there's a video that I've got up along with this chapter about that story and how that was all figured out and everything. So with this, if you have an object that doesn't have any kind of regular shape that you know the volume formula for, there's actually a relatively easy way to measure the volume. Okay, so what you want to do is take a beaker that's big enough to completely submerge whatever object you're trying to measure. And you want to fill that beaker with enough water that once you put the object in, the object will be completely covered in the water. Okay, so yay, little image here. It's not the greatest, but it'll work. So first step is you want to record your initial volume. Okay, so we'll say that this is roughly 13.3 milliliters. Okay, roughly. Don't quote me on that, but yeah. So next thing you want to do is you want to put the object that you're trying to measure in the water. Ta-da. Now, what you'll notice is that the volume of the water seems like it has increased. Okay, but that volume actually doesn't change. The volume of the water doesn't change. So we still have 13.3 milliliters of water in this beaker. Okay, and you know that because you didn't add any extra water to it when you just put the object in. So the increase in volume is all due to that object. So you want to record your final volume. So we'll say this is 22.5 milliliters, okay? And then because we have our units are the same, we can go ahead and do either addition or subtraction, whatever we need to with these. We don't have to worry about derived units, because derived units only come in when you're multiplying or dividing, okay? So if you're doing addition or subtraction, all you need are your units the same. Okay, and then let me get my eraser going here. Okay, so then because the only difference between these two beakers is the volume of the object, you can take your final volume, which is the volume of the water plus the object, and subtract out your initial volume, which is just the volume of the water. And that will leave you with the volume of your object. Okay? So if we do that, it's 22.5 milliliters minus 13.3 milliliters, and you end up with 9.2 milliliters. Okay? And that is the volume of your object. Now, again, physical properties can help identify substances because each compound or element has its own unique set of physical properties. Again, you do want to try to compare more than one. Okay? So you wouldn't want to base everything just on the density. Okay, you want to test a couple other properties to determine what you have. And again, all of this was figured out by Archimedes. Okay, so I'll leave that story for the video on him that is listed in, or that is posted along with this chapter in the notes. So finally, we're going to look at another sample problem here. Okay, we have a sample of aluminum, has a mass of 8.4 grams. the volume of the sample has already been calculated, and it's 3.1 centimeters cubed. So calculate the density of the aluminum, right? So again, we have our density formula is density equals mass divided by volume, okay? And now we've got our mass here is 8.4 grams, and our volume is 3.1 centimeters cubed, okay? So we can just go ahead and plug our values in. So density equals 8.4 grams. That is supposed to be a 4. Come on. There we go. And then over 3.1, and it's centimeters cubed. Okay? So if you go ahead and do that calculation, you end up with your density equals 2.71, and then units, basically you do the exact same thing with the units as you do with the numbers. So we have grams over centimeters cubed, so our units are grams per centimeter cubed. Okay? So density is relatively simple. I'll show you kind of how to manipulate the formula a little bit so that you can calculate different values from it. But we'll do that in class. Okay? So that is it for this section.